Now you can start, ma'am. Thank you, ma'am.
Thank you, ma'am. Good evening, everyone. So today we have a session on segmentation. For this, first of all, as yesterday, many of you were asking how to create a ground truth. So there is one tool available, that is the image J. So first of all, let's see how the segmentation can be created. I mean, the ground truth can be created. So I hope my this tool is visible. Image tool is visible. Oh, okay, it's not visible. Just a minute. Okay, so I hope now it would be visible. So for this, we so for this we need this is the image tool that can be downloaded from image website. This is actually a software type of tool where you will be getting the .exe file, and then you have to install it, and then you can use by clicking it on. So here, how to use this is just one way of doing it. There are various other tools also available. Like one of the online tool is Label Me, that can also be helpful for instant segmentation. That is much more needed. So that is also very good tool, and I'll be demonstrating how this particular one works. So for this, you will have to go to File menu, open it. Then you have any of the image whichever you want to open. Suppose I have this one image, so I select that and open it. So I'll be getting this type of screen where I have the images, the image that I want to segment. So for that, you have to actually you have to select any of the way that you want to do, like square type of segmentation you want to do, or an oval or elliptical type of, or you want to do the polygonal selection, or the freehand one. So let's start on the freehand one, as this is the distorted type of an image. So you can go on by dragging the this thing here, and then you can create the mask. So in while doing this, you have to go to edit option and then select the create mask thing. So here the mask would be created, and then you can save as you save the file. So this is the way you can do the things, like here you can save it. So this is how you can create your ground truth for your things. Like it is very helpful in medical imaging. First of all, like medical imaging is mostly using the segmentation. So you can create the ground truth for your application as well. So after this, I would like to begin with our code for segmentation. So I have a collaboratory file. I have till now, you know how to go to how you open the collaboratory. Just create a new one, and then I'm renaming it to segmentation. And then I have to mount the drive. I have provided the data set to you for smoke detection. So you can mount the drive. So I am mounting it. So it's going to ask me the permission to go to that drive. So I'll give the permission, connect to Google Drive. allow. So in segmentation, what we need to do is that you have two things with you. One is the original image, and then another one is your ground truth image. So you have to find out, you have to train your model on your original image, that this particular pixels are actually of your importance. So those particular pixels need to be learned. So how to read a GIF image? You can read as you read the JPG image. There would be no problem to read the GIF image. Any type of image you can load on that platform. Name of online tool is Image J. So you have with you, the data set I have provided that also contains two folders. One is the image and its respective masks are present. So right now, to access that data set, I'll be going to my particular folder where I have my data set with me. So for this, I'll access the data set path. So I have it in my collab notebook, and here I have this data set. So first of all, you need to do is, as I have provided the zip file, so you need to unzip the file. So when you go to your folder, inside that you will have to unzip it, and we have told you how it unzips. You have to write unzip and then the path, the folder name that you want to unzip, that is the dataset.zip. Mine is already unzipped in this folder, so this command is not going to work. So I'm commenting out here, but you can do this. Then what you need to do is, after this, we will have to get into the path where our images and masks are present. So for this, I will have to give the directory data. Then you have the path where your data set is residing. You would be having a train images as well as your test images with you. So you have to get into the train path. How to unzip the data set? Here we have given the command. We have given you the command unzip. You can see it on screen. Unzip and then the path where your data set is residing. So you can write this. After this, I have one more variable that is going to store all of my images. That is the data path, where my masks are present. That is with name mask slash, and then I have images with me. So I have dir image, which reads all the images. So till this, we have reached our folder. After that, we'll have to do pre-processing. So for that, I am accessing these, I'll have to access these variables. For that, I have created this line. After this, we'll have to import the libraries. So the libraries that we would be needing is import CV2, OS. Then I have import TensorFlow STF. Import Keras. Import Keras.models. Import Keras.models. Sorry, from Keras.models. Import all from Keras.models. Import all. Then I have to import the NumPy. Import NumPy as NP. Import matplotlib.pyplot. Matplotlib.pyplot as PLT. So these are the libraries we'll be needing. So after that, I'll be defining the number of classes that we have. So input height and width, the dimension of our images that is to be resized. Input height, comma, input width. Input width is equal to 128 by 128. Then I have input. Once we have given our input, we'll have to give the output height and width also. So I have output height as 128 by 128. Output width equals to 128 by 128. After this, we'll need to pre-process the data. Someone is asking that how to create a mask for all the images using code. So you can go for image processing tool like Otsu's or thresholding based methods that can provide you some type of segmentation thing, but it's not it might be possible that your particular region which you want to segment that may not be correctly uh, formed in the output. So you can try that. Then after this, we need to resize or pre-process the all the training images. The pre-processing thing needs to be done where we have to resize it, normalize it, and store it in array, both the ground truth as well as your original images. So we have a pre-processing. Uh, till here, anything, should I wait or should I continue? Should I go ahead? Okay, thank you. So I'll move ahead. So after this, we need to pre-process the data. For this, we need two functions. One is for pre-processing the original image. Another one is for your segmentation ground truth. So here we have def get image array as one of my function where I'll be storing my images by resizing it and normalizing it. I'll be passing the path of my folder, or the images one by one would be read. So that would be resized into particular size, that is the input width and height that we have provided. So img would store the image by reading it using cv2.imread, cv2.imread, where I have a path, and then I'll be having img is equal to np.float, and then resize it to the dimension that we have provided in our previous cell. That was the width and height, width comma height, HEI. Then we need to normalize the images, so we'll divide it by 255. So this would return me the image zip file error. Sir, I think there would be some typo or some path error. That's why you would be not getting the unzipped as your output file. Some of your maybe your path would not be correctly given. So after this, you have to write one more function for getting your output. Getting your ground truth. So we have a function as get segmentation array, where again we'll be having the path as well as the number of classes and width and height into which we want to we have our ground truth available. So width, height, then I have one variable named as seg labels that would be having zeros, np.zeros, where I'll be passing the height and width, width, and the number of classes that we have. So in this array, this would be initially having only zeros with it. And classes would be this parameter. So after this, I'll have to read my image using cv2.imread. Then I have to resize it using cv2.resize. My previous image, red image, would be passed using the width and height, width and height. Then I'll have to store the pixels of each of the class in this array. So for suppose there would be some pixels that would be having black color and some would be having white color. So the pixel that would be having black and white, that needs to be stored. So for that, this for loop is used, that would be iterating for the number of classes till the number of classes are run. So here my seg labels. In the class that is red, that is 0 or 1. In this for loop, there the pixels would be stored. So for this line is used, that you have suppose black pixels and it would be stored in that particular seg labels location. Dot s type is int. Then I'll have to return whatever is red that is stored in seg label. Now, after this, the important thing is that you need to sort the images. There might be possibility that your images are not actually sorted out in means your mask and images are in unsorted way. So you need to sort it in the ascending order. So here for this os.list dir, it's going to read your directory image. And after that, you will sort this using dot sort function. So images dot sort. Then you have your segmentations with you as well. So this would also be requiring the sorting. So os dot list dir, where I have the path of dir seg where these images are stored. So inside that you have to sort it. So you have segmentation dot sort in a similar fashion. So after this, we also need to store the images in. So there are various images, so we need to store them in a list. So for that, we'll be having one empty list with us for storing the training original images, as well as another one using the y variable list, as that would be storing your mask. For this, we'll be having a loop that would read each of these images, and it's going to pre-process it using the function that we have defined in our previous cell. So we have the variable im and seg that would be reading the images in zip manner. So because we have so many images with us, so it's going to be in zip, and it would be stored in im and seg that would be accessed later. So I'll have to append one after the other. X dot append get image array was our function name. That would be reading the path first of all, that we have the dir image, the original path, along with it the images that we have read right now in our for loop from the im variable. So this is the path we have provided. Then I have my input width width. Then I have the input height as well. Input height. So similarly, I'll have to append the y, that is the ground truth or mask with us. So I have y dot append get segmentation. Then I'll pass the path dir number of classes, sorry, underscore n underscore classes, that is our variable we have defined. Then I have the output width and height. So after this, we'll be having x and y will have np dot array, and I'll give y in this. So this is all we need. So let's check what the shape it's going to give. So there is one error. X dot append. Somewhere I've written wrong name actually. Variable name or something is missing in the function. Only one size arrays can be converted to Python scalar. Okay, so there were actually two mistakes. I have not written float 32 because of which I was having my previous error, and then my function name was wrongly written. So now we'll try to print the shape of this x and y variables. So I have x dot shape and my y dot shape. So I have 20 by 128 by 128 across three original image, and its ground truth is here as 20 by 128, 128 by 1. So, so I have, so I think you can write this code. Till that time, I'll paste it. So I'll wait for 2 minutes so that you can write this line of code. See, number of classes equals to 1 we have taken because I have one labeling as smoke over here. So that is why I've taken 1. I was actually waiting so that you can do this code. Should I proceed? I think till here the things would be clear. So after this, we'll try to see one of the image. So we'll try to visualize. we'll try to visualize the image that we have read. For this, I'll be taking one of the variable that would be having my np.array os.list dir. Inside this, my segmentation path I'll be providing. So I have another variable named as fnm that has ld. Suppose third or our first image we are seeing. So for this, we'll print fnm cv2.imread is going to read all of my images with the corresponding index value that I have provided in my FNM. There I have dir seg that would be added to the value that would split my first index os. I'll use os dot path dot split text that would split my text of fnm, that is fnm, and I'll pass the index value as 0. So whatever the numbering is, suppose I have numbering of my image as image 101. So after your dot, it's going to split the text. So for another variable, I have fnm equals to ffnm plus my jpg image. So one is in jpg format, another one is in tiff. So for that, I have done this. Image is equal to cv2 dot imread dir image image as well as its corresponding ground truth dot figure fig size is equal to 5 by 5. So for this ax is equal to fig dot add subplot first row first column my first image. Then I have ax dot imshow to display it. Ax dot my first title is set title, my original image. So this would be the first title. Then I have to plot it. So I'll give plt.show so that it displays. In similar way, I'll be giving my segmentation image as well. So for this, I'll pass my seg variable here and segmented image. for my segmented mask. Not convert to float. So there is some error. Okay, so I had not written .jpg because of that. It was in my actual images, it's .jpg, so it has a split with the original name over here, and it was not able to read this .jpg. It was only jpg written. So as it can be seen here that this is the original image and its corresponding round truth is this one. So you can visualize it, you can change the index value and see other images as well. So once we have seen that, yes, its corresponding round truth can be read. So after this, we can start building our model. So I'll wait for just a minute, just a couple of seconds so that you can complete this one. So there is a question how to generate mask as ground truth. See, mask and ground truth are the same thing that we are using a different name for the same thing. This is the ground truth that we want to train our model into. So we can generate it using the tool that I have told. You can create it yourself, or you can have the inbuilt one, some data set provided, so you can use that directly. Okay, so I hope this was what you want to ask. So after model building, uh, image can generate binary image as one particular region from image. Yes, it builds, as I have displayed it, it builds the binary image. Okay, the polygonal shape is also available. So for instant segmentation, you can use the polygonal shape, as well as label me tool is very effective for that. No audio. Am I not audible clearly? How to convert scene image to text? See, for scene image to text, you will have to give the ground truth as the text. So you will have to write something like someone is playing football in a ground. So these types of ground truth would be required. It's not about segmentation. So that is the other type of application, not it cannot be combined with segmentation. So for building our model, we again require the height and width. I'm giving different variable here. You can use the above variable that I have given, but I'll use different variable. Okay, then image height, same as we have provided. So this would be taken as an input in our model, is equal to 128. Then I have my image channel, that is the RGB image we are using. So I have 3. Then inputs would be taken as tf.keras layers.input. Uh, then I'll be passing these variables here. So I have image height, width, and channel. IMJS code. Then this input would be given to the first layer of our CNN model. So I have C1 as tf.layers .conf 2D. Then 16 filters of 3 by 3 dimension, and activation function as ReLU, as we take always ReLU. Then I have then another variable would be storing. uh, I'll be giving the dropout here, tf.keras .layers .dropout. Sorry, here I've written P1 is equal to TF dot Keras. Another convolutional layer I'll be making. So there are two set of convolution here, and after that we'll do max pooling. So I have conv 2D layers.conv 2D, and again I'll be having 16 filters of size 3 by 3. Then activation as ReLU, and padding same. I'll pass my previous layers input here. So after that, I'll do the max pooling on this. So I have tf dot keras dot layers dot max pooling 2D. Sorry. So in a similar way, another set of convolution layers are to be made. Why 16, why not 32? You can take 32 also. There is no problem. Making your model is up to you. Okay, so there is no rule that you cannot use 32 over here. You can use. So another convolutional layer I'm adding. So tf.keras.layers convolution 2D of 16 filter size, 3 by 3 filter size we have. Then I have activation as ReLU, and padding same. I'll pass P1 here, and then I'll use another convolutional layer, tf dot keras dot layers activation as ReLU, and padding same. So this is the encoder. So this is first of all the encoder, where we have used max pool to downsample the features, and after that we will upsample them using conv 2D transpose. So right now we are building a small model that is only having 4 convolutions with it in the encoder side, and logic when you upsample them. So I have gone 2D transpose of size 2 by 2 and strides that I'm taking is 2 by 2. This is also up to you how you take the stride. You can take 1 by 1 also. Padding is equal to same. Then I'll have a concatenate layer. So why I'll be having this one is, let me explain. There are skip connections used. Usually in segmentation, you can see that there are, I hope my screen, this PPT is visible to you. Can you please respond? My PPT is visible. Okay, thank you. Passed to our next output over our encoder side, sorry, decoder side. So for that, to make that skip connection and to add our previous features that were passed through the convolutional layer 4, in between a concatenate operation is to be performed, so that you can perform the skip in between the features, and from the output that is coming directly from the encoder part, that can be added to it. So for this purpose, I'll be using my next layer, tf.keras. This operation can was well explained in the unit architecture. Here in this unit architecture, you can see here various skip connections are used in between to directly transfer the feature maps. Okay. So I was here, I was concatenating the features coming from my con 2D second convolutional layer, concatenate U1, comma C1. Then I will add one more convolutional layer, tf.keras.layers con 2D. With 16 filters of 3 by 3 size, activation as ReLU, and padding same. Then there is 3 by 3 size. Then I have activation as value and padding same. Need to pass the input here U1 and here C3. After this, the final output layer where I'll be getting my final segmented output. For that, we need Keras dot layers dot con 2D. But this time it would be having one equal to sigmoid. So please try to build the model till here. I'll wait for a minute so that you can build your model. You can change the layers also. It's not necessary that you build it with same type of fashion. So you can change the layers. Manojit sir, in place at the Keras, in place of this, how we can extract only unique features from layers. You can put the flatten layer over there and then extract the features at that particular layer and see the output and take out that output. Okay, that directly that output you can take it out or you can use the flatten over there. Another doubt was that how to, what is the purpose of dropout? So dropout is a regularization technique that is used to reduce the overfitting problem. So we will continue. So after building the model, we will we will print the summary of this model. So we have model.summary. Sorry, first of all, we need to define this model. So we have model equals to tf.keras.model inputs, as it was given earlier, it was inputs. And then we have output. Um, my runtime is getting disconnected. Let me reconnect it. Okay, so it's displayed over here. You can see that this was the first convolutional layer. It's having 128, 128 by 16. 16 filters we have passed, then a dropout, and then convolutional. Here the upsampling is done here in con 2D transpose. This max pooling has downsampled it to 64. And then we have upsampled it by using con 2D transpose. And then we have concatenated our second convolutional layer features directly to the output of this con 2D transpose. So in this way, you can build your own model. You can change the layers. You can add similar type of layers by using different number of filters. So using 16, someone was asking 32 can be used. You can use 32 number of filters, and more max pooling layers you can add. So for compiling, we'll need optimizer. We'll have to import, as I have not imported it. So after this, before that, we need to first of all uh, use the validation as well as training. So let us split the training set into validation and training data. So from sklearn, for this we need to have the import shuffle. My train rate is 0.9. Then I'll be giving my training index. np.random.choice. For index value of validation, I'll store this in index val. where I have one list where I have my previous training, and with that, here I have stored my index train. So that would be subtracted. So a list set a range in between X shape, that is the original images, X shape, that were the 20 images that we were using of 0, and that would be subtracted with the index value that we have got from index train. So here is the index train. After this, we need to shuffle these things. So for that, we have already imported it from sklearn library. So we'll use the shuffle x comma y. Then I have x train comma y train is equal to x index that we have index train, and then we'll pass y inside that. Also we'll give the same index value. Then I have to give validation also. So x val comma y val. In a similar way, we'll pass the index validation indexes that we have got while splitting the values. Here I'll have to give the index val. This would consist all the remaining indices. Of these x train and y train that we have run. So we'll print the shape, print x underscore train dot shape comma y train dot shape. Okay, this cell is not run. That's why it's getting disconnected at my end again and again. Sorry, spelling mistake. So it's giving that 18 images are there in training, and then testing would be having 2 images. So let's print the validation as well. We have x underscore val dot shape. How to check the accuracy? In segmentation, mostly accuracy is not seen. Mostly IOU and dice or Jacquard index, these things are seen. So that is actually from keras.iou. That from keras library you can see. In the same way we give accuracy, in the same way mean IOU can also be given. So so after this we have to first of all compile our model. For that, I have to import optimizer, and then we have to fit the model. So right now I'm giving, sorry, Adam. I'll be using Adam optimizer and Adam as tf.keras.model inputs is equal to inputs outputs is equal to outputs. So my model, I have built this model earlier where I have printed my summary. So actually I have to give my Adam optimizer learning rate here, and I have my Adam optimizer with me. So I was actually building the model again, but I have done this in my previous cell. So here I have to give my optimizer tf.optimizer.adam, and the learning rate I'll be giving is 0.0001. You can change this. And then I have my model compile. So model.compile. Here I'll be passing Adam as optimizer. Optimizer is equal to Adam. Then we have a loss as binary cross entropy. Binary cross entropy loss function we'll be using. So let's compile this. As no optimizer here, spelling mistake is there. I have to give optimizers. So it says it should use learning rate. So after compiling my model, I'll have to fit this. Result is equal to model dot fit. Then pass the x train and y train variables here. X train, that are the original images, and y train has our ground truth with it. And then the validation, as we have split it in the ratio of 90:10. So validation data is equal to, we'll be having x val. This was x val and y val. These were the variables. Then a batch size of right now I'm using 2. You can change it. We have less number of images, so I'm using a smaller batch size. You can change this. Even epochs I'm taking less. You can write this code and try to run it. I'll wait for 2 minutes. because my this session is getting crashed. So let me reconnect it. You can ask queries if you have any. So this model is trained. This was a very small model and very less number of images. It's getting trained. Otherwise, it usually model takes time to build, to run. So now we will plot the graph of our loss. There is a question here. We have taken 18 images. What's the minimum number of images we should take for training? There is no minimum or maximum thing. Usually, you should take large number of images. Otherwise, result cannot be found good. So it's up to you that how many images you can use. You can also augment the images if you have lesser number of images with you. That can help in training and getting better output. I have used less because then more number of images and creating the ground truth and using resizing it and training it takes a lot of time. Loss graph that we have, validation loss. So PLT dot plot results dot history result. So I have a variable results that I'm using, results dot history key comma label is equal to key. Then plot dot legend and so this was the type of graph we were getting. You may get a different graph. After this, we'll try to predict the predictions, how our images would be printed. So how much overlapping would be there. So for that, we have a few testing images with us. So I have my path given over here. So I'll take the same path, but I'll have my test folder inside it. Test, and this name I'll change as test. So it would read my testing images. So the code that was earlier given to you, uh, that same resizing and rescaling thing we will use in testing also. So we'll rename a few of the variables and we'll use the same pre-processing code. So I have here so same pre-processing would be done, but I'll have to give my test that would store our testing images inside it. So for that, I'll rename these variables. Uh, I'll rename them to test, so that a new variable would store all of my new testing images, and I'll have to pass my test path, the original path that has the testing images inside it, that needs to be passed here. So after that, I have to print this, then y test, and we have a numpy array of my x test and y test. Sorry, here also I'll have to rename. So let's print the shape. Print x underscore test dot shape. And then we have y test dot shape. Test dot shape. So it's giving me 5 by 138, 128 by 128 by 3. This is my testing images. So first of all, we need to give the model dot predict. So we need to predict the how the model is performing. For that, you have preds underscore test is equal to model dot predict function that we were all earlier also using. Is equal to 1. Here we are using 18 images for our training right now, but we should use more number of images so that we can get a good output. This is very less number of images we are using. On small data set, yeah, it may be overfitted. On small data set, 100% accuracy is not that good. So we will have one more variable, y pred I. We'll try to visualize the images. Someone was asking how to calculate mean dice IOU. Uh, that can be calculated using these predict function. The ypred I and y test I, that is the prediction of your this thing. The predictions that we are using here, ypred test is having the prediction stored of your X test data set. So using that, IOU and DICE can be calculated. Its formula is available, would be available on internet, but if time permits, I will try to demonstrate it. But first of all, I'll try to demonstrate the visualization of the result. Dot as type np dot int np dot uint 8. This is just to convert it. So to visualize it, there is nothing. That is one Seaborn. Just a minute, let me write the code of this function that would be used during the visualization when we will plot all of the original images, its prediction and the ground truth simultaneously. Import Seaborn as SNS. I'll explain it. First of all, give me time to write it. So this is a function where various types of colors you can give, and that color can be varied using the color palette function that is I'll explain this quickly for once I'll write this. Seg image img is equal to np dot zeros Take shape of 0. Float colors equals to SNS dot color palette. Please show object recognition result of image. I think you want to see how it's giving the output, means predicted image. That is what I am trying to do. SNS dot color palette, comma n classes for Cn. So this will take the range of the classes that we have. That we have right now only one range and underscore classes. Seg image. It would read all of the 0th channel, and that would be added to something that would be multiplied using the color palette. Some of the value that would be given in colors. So colors C of 0, the index of the class that is taken from the for loop. So in similar way, other color channels would also be manipulated. You will come to know about it when we will see the result. So there it would be quite visible why these things are added. 0, 1, 2. Then I have here 2. Yes, the documentation of this would be available, as well as I have provided it in your lab 9 folder. Uh, there might be some internet issue at my end. That's why voice is breaking. Even my collab file is getting disconnected. Yeah, I have provided the documentation thing already in your lab folder file. Everything which I have done here is given to you prior to this lab. So this function would be needed while we'll be plotting the our original image and predicted images. So right now we'll try to plot using a for loop. So I have a for loop that would be having for I in range. I have 5 images with me, so I'll print all 5 in range of 5, and then I have images that is taken from X test of I. Then I'll have to give my predicted image also. So I have my y pred I pred I storing this predicted image. So here I'll have to give y pred I of I that is in range of 5. Then the test image y test I have not given this y test I'll have to provide this also. So let me predict this I test this is nothing but the original ground truth that we have given in y test. That is the same. That would be the same stored in this variable. Okay, so that is only the thing that we need to give. That would be read in our function of plotting, so that we can see side by side each of the image, how much comparative analysis can be done. For that, I need to store this. Nothing else is to be done here. So mapfig equals to plt dot figure fig size is given as 20 by 40. Ax is equal to fig dot add underscore of subplot. First row, 3 images we'll be printing. So I have ax dot im show images that is normalized to 255, 0 to 255, 0 to 1 range. I have normalized it. So I'll give the title as set title. Inside that, I'll be giving original image. So this would be my original image. And in similar way, I'll be giving my other predicted image as well as my original ground truth. So I have ax equals to fig dot add plot. Add subplot 1 3 my second image. Then I have image is 255 and I'll have to show it. Ax dot im show. I'll have to, as the previous function name I have used, that would be required here to show the overlapping, how much it is doing. For that, I have built that function. So that would be taken over here, and I'll be passing my segmentation output. That is the predicted output over here, along with the number of classes that I have to take. So right now, alpha channel is taken as 0.5 for the transparency, how much we want to give. And here we'll be giving it as prediction. This is my predicted image. Then in similar way, I'll be having my original image with me. So for original image, I don't have to give my image. Actually, my predicted image is overlapped over my original image. So I have passed, I've given this image. Image is first printed, and after that, it would go to the function that pre-processes it, that processes these images and set the alpha channel as 0.5. So after this, we have to pass the segmentation test results. Inside this, I have it in seg test. I think, yes, this is my seg test. Here I have my ground truth with me. So this third column would be the ground truth image. Ground truth. plt.show. Sorry, function. No, Cbon, I have not imported it. Okay. So I'll have to import. I have import this. Our module Cbon has no attribute color palette. So here's something I've written wrong. Because it has HLS and classes. So we'll be getting this type of result once this code is running. I've given the code in your lab 9 file, And you will be getting these types of predictions with you. Here the middle column is showing you the predicted images. Here see these images are close to the ground truth, so you may get these types of predictions with you. So if you are not getting the prediction, then there might be a possibility that you have a small that code, the model that we have written, that would be quite small. So because of that, you may get not good results. But even that, if you increase the training images and you increase the model size by making more such modules, by making max pooling layer and downsampling it and then upsampling it, that may resolve your issue, and then you may uh, get good predictions as well. So uh, if you have any query, you can write over here. Suppose while training large images in Collab, after 12 hours it gets disconnected. How can we continue from where it got disconnected, the model we are training? So Manjunath, sir, uh, you can save your weights by using check. Uh, you can use save your weights at each of the say using save weights from Keras library. That save weights save best weights. Whenever your model gets the best weight, it saves it on your drive, and then you can continue from that thing. Another thing is that you have actually you have now a Collab Pro version available. So those provide you more access time to your notebook, as well as it provides you high GPU that can give you better training time. So a lesser number of disconnections occur in that case. So you can upgrade the collab that we are right now using, that is the free version, so it doesn't provide much of the GPU capacity. Can we use the code for X-ray image and segmentation? Yes, yes, sir. You can use this code for X-ray image segmentation as well. Even for any type of segmentation thing where you have a ground truth available with you, this code would be beneficial to you. And another thing is that if you have multi classes available to you, then you can increase the number of classes to 2, 3, or 4, and then you can try it out. And remember to change the output layer over here, the number of neurons over here, so that the output would be affected according to your number of classes. Handwritten text handwritten text segmentation. Um, Handwritten text segmentation. Yeah, you can call it segmentation if you are talking in this sense, and you have a ground truth, like you have A written, and that A is in form of the ground truth, that is the labeling 0 or 1, I mean black or white pixel. Then yes, you can say that it can be segmentation. But it depends how you have the application, or how the input you are giving it to your model. We train all the images all together. Yes, sir. Yes, ma'am. Kalpana ma'am is asking, we train all the images all together. Uh, you train till the time you have lesser amount of images with you, and you are resizing it to a small, like 128, that much RAM is capable to take into that much amount of data. You can train it on that much data set. But once your images, if suppose you have a lot of images with you, suppose there are 20 or 30,000 images, then you can break it into 5,000 chunks, and then train those 5,000 images, save the weights, load those weights, and then train it on next 5,000 batch. That would be helpful if you have a lot number of images. If you have smaller number of images, then you can go in a single go. Then another question. Will this segment more objects in the same image? Ma'am, I'm not able to get your question. Will this segment more objects in images? Collab Pro is available in India, but you need a credit card to access it. Collab Pro is available. Collab Pro is available in India. Okay. We Can you please demonstrate with an example on how to generate ground truth from an image? Sir, Justin Verghese is asking to demonstrate how to generate ground truth from an image. In my lecture, when I have started today the lab, I have demonstrated an image to create a ground truth. You can view the recording. So images software demonstration I have already provided. Suppose you uh, we apply the batch normalization means what do you want to ask, Kalpana ma'am? We apply batch normalization. You have segmented only one object. I'm asking if you can say, yeah, yes, ma'am, you can segment. I have told you that you can segment more number of objects in a single image and you can give them different pixel value. I mean, different color value like gray you can give or gray, red, yellow, any type of color you can give. For that thing also, segmentation round to this can be helpful. Okay, the number of classes there, in that case, the number of classes would differ. That is the only thing. What is the number of stride in this model? In mid of one of the layer here in con 2D transpose, you can see that I have used a stride of 2 by 2. So 2 by 2 in this model. So this model won't be much effective for much larger number of images, as this is just a display how you can build your model for segmentation. That was just the aim. So in the similar fashion, by varying the number of filters and varying the stride size, max pooling layer and con 2D transpose and making more different type of skip connections, you can use the model. Okay, how to calculate Kumar sir is asking how to calculate IUU and dice coefficient. So, sir, in Keras library, I have told the way we have calculated the your accuracy in compile. We write where is my compile? Compile matrix is equal to accuracy, where we provide matrix equals to accuracy. There you can give matrix equals to mean IOU. That would help you to check your IOU thing. Okay, and dice IOU, I have given you the predicted images, how you can find out the predictions here model.predict, and I have stored it in this cell. So using that, you can build a formula for that for the prediction as well. That prediction is given is provided like ground truth overlapping, union over intersection over union, that is the IOU. So that can be built. So where was my here I was writing matrix equals to MIUU, that is provided by Keras. So you can visualize that during your training, and for testing you can make the function to check it. In 2 hour session, actually the everything to complete that becomes quite difficult. So the maximum thing which I can demonstrate, I have tried to compile it all together. When we create ground truth mask, how good we should draw a boundary, how much it depend on our output segment. So yes, sir, there are few applications like for medical segmentation. Your boundary should be precise and accurate. So for that, uh, what we say, the people, the experts who have the knowledge, their recommendation is actually needed. So for certain application, yes, the boundary should be quite precise, but in some cases where suppose we are segmenting the person or a cat, a small amount of difference can be accepted. And you have more I mean a polygonal shape also over there, so you can make that type of segmented output boundary also. Name of detected object class, name of detected object classes per, you can check that using the color that it shows in the your this output, as I have shown it in black and red color, where black color was giving you the output of your final segmentation result. Which models are best for brain MRI images segmentation? One of the famous model is the unit model that Oja ma'am has yesterday discussed. And I have to today also I have shown that when I was talking about the skip connection. So that is one of the application. Other than that, there are various types of more enhanced models right now available. Unit was the basic model which was initially came into existence, during which the segmentation was initially started at that time. So it was basically during 2015-16. But right now you have more models based on the same structure, same type of encoding decoding structure. Models are decided by data and use case. Yes, sir, you can say that model can be are decided, but you will have to try out certain uh, addition of layers, adding some more things, fine tuning that which thing might work on your application. So yes, certainly it depends on your data as well as on your model. Your output depends. I hope I have answered maximum questions which I can give.
Yes, ma'am. I